In example 1, we have a cookie company that claims that their cookies have an average of 24 chips per cookie. I want to know if actually I think they might be lying, and I think the mean might actually be lower than that. So I take a sample of 40 cookies, and in my sample there was an average of 22 chocolate chips per cookie, and the standard deviation was 3.8. Now, as in example 2, we really need to understand what the observational units and the variable is and what kind of variable we have before we can get into the null and alternative hypothesis. So in this case, the observational units are the cookies, and the variable, what piece of data was recorded from each cookie, was the number of chips. And you have to be careful because the variable is not the average number of chips. I had a bag of 40 cookies, and I tore each cookie apart and counted how many chips were in it. And so I recorded cookie number 1 had this many chips, cookie number 2 had this many chips, cookie number 3 had this many chips. So the number of chips and not the average number of chips is our variable in this case, and that in fact is a quantitative variable. So that means that my parameter is going to have symbol mu. Okay, so again, the Greek letter mu, it's kind of like the English letter U, but it has this long tail on the left-hand side. So as soon as I know that my variable is quantitative, then I know my parameter symbol is going to be mu. And my null and alternative hypotheses are always about the parameter. So even though I wasn't asked to, over here I'm going to explain and describe what mu is in this case. So mu is about the entire population of cookies. So this would be the average or mean number of chips in all cookies made by this company. So the parameter is about the all as opposed to the small. The small is the sample, the subset that we took. The all is the entire population. So the parameter mu is not a long run average. The description doesn't start with the long run, but it's about all, and I would underline the word all whenever you're defining that. All right, so the null hypothesis, again, we're now expanding on what we had done previously. This null hypothesis is not really about the random chance, but we're going to assume that the company's claim is correct and that the average for all their cookies is in fact 24. And then the alternative, what I'm trying to find out and what I'm conjecturing is that the mean is actually lower than 24, so mu less than 24. Now again, it's really important to think about the difference between what these say with a mu and what happened with the sample. When I took a sample of 40 cookies, I found the number of chips in each of those 40 cookies. I had 40 numbers, and then I found the average of those 40 numbers, and I got 22. I know that 22 is less than 24. I don't have to do any work to understand that. It's absolutely true. But 22 is not mu. 22 is, we're going to do that in part B, about the sample. 22 is the sample mean. So I'm using that sample mean to try to make a conclusion about the whole population's mean. All right, so if I were going to write this in words, the average number of chips in all cookies. So I'm rewriting what the symbol mu stands for, made by this company, is 24. So again, I don't know the value of the parameter, but I'm going to assume that it's 24 just to be able to run my analysis. And then the alternative, the average number of chips in all cookies made by this manufacturer. So again, this is about, the hypotheses are about the all, they're about the whole population. And my alternative conjecture is actually that that average is less than 24. All right, our symbols for the number 40. There were 40 cookies. That's the sample size. So the symbol there is N. 22 was the mean from the sample of 40 cookies that I took. So since my variable is quantitative, the symbol for the statistic is X bar, the sample mean. And now 3.8 is the sample standard deviation that has letter symbol S. All right, now part C is asking us to calculate a different standard deviation. It's the standard deviation of what we call the t-distribution, or what we would refer to as the null distribution, right? So the t-distribution based on the null hypothesis, that would be the null distribution. And S over the square root of N is an approximation or an estimation for the standard deviation of the null distribution. Okay, so when we do a simulation where we keep taking random samples of, whoops, sorry, I shouldn't talk and write at the same time. Hang on. Right, if we had a population in which the mean was 24, we assumed that, and the standard deviation was 3.8, and we kept taking random samples, then figuring out the mean from each random sample, and we made a distribution of those sample means, that would be the null distribution. And this S over square root of N, which is on your formula sheet, is the standard deviation of that null distribution. That is S, the standard deviation of the sample, over the square root of the sample size. So here's where, again, you can get confused and make mistakes because we have two different standard deviations that we're dealing with. We have the sample standard deviation of 3.8, and then we have this null distribution standard deviation. Now you should pause the video and put this into your own technology to make sure that you can get the correct answer, and you should get 0.601. And if you don't, then you have to let me know, and we have to figure out why you're not getting the right thing. All right, then in part D, the t-score, which is the standardized statistic. So again, you have the formula on your formula sheet. It's written out in words. So in this case, we're going to use t instead of z because our variable is quantitative. We're going to take our sample mean minus the assumed value in the null hypothesis, that's the mean of the null distribution, and then we have to divide by the standard deviation of the null distribution. So here's a very, very common student mistake, is to put instead of putting 0.601 in the denominator here, to put 3.8. 3.8 is not the right standard deviation for this formula. 3.8 is the standard deviation of the sample, and the 0.601 is the standard deviation of the null distribution, and that's the standard deviation that we need in this case. Now again, you should pause the video and calculate this on your own technology to make sure you're getting the right answer, and you should get negative 3.33. If you don't get that, then you need to let me know so we can figure out what's going wrong. The most common mistake in this case would be that if you weren't using parentheses and you typed this all in a row, 22 minus 24 divided by 0.601, your calculator would do the division before the subtraction. So that's the first thing that I would check. So you may want to do the subtraction, get an answer from that, and then separately take that answer and do the division. All right, now you can look at your formula sheet and look at your strength guidelines chart and figure out if your t-score is negative 3.33, what strength of evidence are we talking about? Against the null hypothesis, this would be very strong evidence against the null hypothesis. That's again what I call the initial conclusion, right, when we talk about against the null. But then we want a conclusion about the research conjecture. The research conjecture was the alternative hypothesis. So if we have very strong evidence against the null hypothesis, that means the null hypothesis is probably not the truth. We have very strong evidence against that. So the alternative is probably the truth. But I say probably because we don't actually know what the truth is. But we have very strong evidence that mu, and I would I don't want you to just write the letter mu. I want you to write out all the words. The average number of chips for all cookies, this is about the whole population made by this company, is less than 24. Okay, so again, our conclusion is about all of the cookies that this company makes, not the sample of 40 cookies that I took. I already know about the average from that sample of 40 cookies, but I want to make a statement about all the cookies that they make. So our sample mean did turn out to be less than 24, but our question was really whether that's a sample mean of 22 is in the tail of a null distribution where the center is at 24. So let's take a look at that. We're going to go to the theory-based inference applet. And now our scenario is not one proportion, it's one mean. And we're still going to put in our sample size n, in this case 40, and our sample mean, in this case 22, and our sample standard deviation, in this case 3.8. Now, depending on the kind of computer you have, you don't have to hit calculate necessarily. The picture is not very useful in this case. But we want to go over to theory-based inference and do test of significance. So we want to put in the number in the null hypothesis of 24, and you'll notice that once you click out of that, the applet automatically puts 24 in the box for the alternative hypothesis. So the null and alternative hypotheses should always have be about the same number. Now the null is saying that mu equals 24. Remember, we don't know the value of mu, but we're making an assumption about it to be able to do our testing. And then the alternative research conjecture was that mu is less than 24. So if we do the calculation there, first of all, notice the t-score, negative 3.33, so that's the same as what we calculated. And then our p-value is 0.001. So in this picture, with this blue curve, that is a theory-based curve. It is an approximation of what would happen if we were to simulate by taking samples of size 40 from a population whose mean was 24 and kept calculating the mean of each new sample that we would take through simulation. And this along the horizontal is all the different sample means that we might expect to get. So remember that even if in the population the sample is 24 chips per cookie, if we take a sample of cookies, the average from that sample is not necessarily going to be 24. So this graph gives us kind of a picture of the different X-bar sample means that we might expect to get. But you see that the sample mean of 22 is way down in the left tail, and that vertical blue line kind of shows you where that is. By the way, notice the mean of 24 and the standard deviation of 0.601 in the upper left part of the graph. That's what we calculated, that standard deviation a little bit earlier. Right? And so that sample mean value is in the left tail. It has a t-score of negative 3.33, and we're going to go back and interpret that, and then we have a p-value of 0.001, which means it is highly unlikely to see a sample mean as low as 22 if the mean in the population really was 24. Now I have to go back because I just realized I didn't do my interpretation. So the sample mean, which is x bar equal 22, is, I'm just going to say more than 3, but you could say 3.33, or you could say almost 3.5 SDs, and I'm going to say again below, because that t-score was negative, the mean, which would be 24, of the null distribution. So anytime we get a statistic that's more than 3 standard deviations away from the center of the null distribution, then we have very strong evidence against the null hypothesis. And then it's a good idea, again, to look at your strength guidelines chart. The strength from the p-value is also very strong because 0.001 is less than 0.01, so that's the bottom row of the chart of the strength guidelines. And so that matches the strength that we got from the standardized statistic t-score.